Good morning, Townview. Welcome back to Chemistry Online.
Let's go ahead and get started. So today we're going to be talking about stoichiometry. So top of your page, we're going to write stoichiometry. And our focus today is going to be on mole to mole. Mole to mole is what's called one-step conversions. And by the end of class today, we're going to be working on two-step conversions. Next time I see you, we're going to be working on three-step. Today's focus, though, is going to be one- and two-step conversions. All right, let's move on. So first of all, what is a chemical equation? Can anyone tell me what a chemical equation is? It consists of two things. Reactants and then products. Good. So I'll go ahead and write out an equation for you guys. So hydrogen plus oxygen will yield H2O. Is this a balanced equation? No, it's not a balanced equation. What's wrong with my two diatomic elements? All right, they're singular. They should be in pairs. So H2 and O2. Is it balanced now? No. To balance this, I have to double my hydrogen, double my water. Now I have a balanced equation. Okay? So what do the coefficients in a chemical equation represent? If you don't know any of these terms, make sure you write them down because these are going to be real important. So what do the coefficients represent? So the coefficients, they represent the number of moles. Okay? So if I have two H2s, that means I have 2 moles of H2. How does that work? So H2 is a hydrogen that's single bonded to another hydrogen, and then we just have 2 of those. So there's one of the molecules, there's the other molecules. How many molecules of oxygen gas do I have? Just 1. So there's my oxygen gas right there. How many molecules of water do I have? Is it 1? Look at the equation. All right, so based on the equation, I should have 2. So that's basically what that is right there. So the coefficient, that's this number here, and it represents the number of moles. What about this little number? What does that represent? All right, it is the subscript. What does it represent? All right, so it's how many atoms are in that molecule. So in the case of H2, we have 2 hydrogens that are bonded to each other. That's what the 2 represents. So 2 atoms in that molecule. All right, these next 2 terms, they have their own teak. We're not going to cover that teak today, but I do want you to know these terms. Can anyone tell me what they think a limiting reactant is? So you know what a reactant is. It's that term right there. What is a limiting reactant?
Is it like when you have like a equation and like you need, it was like the horchata thing where when you didn't have enough of like one product that was a limiting reactant because like it limits the amount of like products you have?
All right, good. So the limiting reactant, there's 2 things you need to know about it. One, it's the thing that runs out first. Another thing you need to know about it is it determines how many products you get to make. So think about it like this. I have 10 boxes of graham crackers, 2 bags of marshmallows, but I only have 1 tiny piece of chocolate. How many s'mores can I make? I can make 1 s'more. What is my limiting reactant? The chocolate. So your limiting reactant, it determines how much product you can actually make. Limiting reactants are really important. You're going to be tested on them later. What about excess reactant? This is a term that you're going to see a lot. You just need to know what it means. What does excess mean? This one will not run out. Will not run out. Or as the Canadians say, will not run out. Will not run out. I'll tell them you said that. All right, let's move on. So here we have a couple of practice problems from last 9 weeks. I want to see if you guys can remember how to do this. I'm going to give you all 5 laps, and then we're going to go over both of them. So let's go ahead. 5 laps. You got this? All right, let's go ahead and go over these real quick. So first one says, what is the molar mass of calcium hydroxide? What's the first thing we need to do to solve this? We need the formula, right? So calcium is going to be Ca. Hydroxide is OH. What's the charge on calcium? +2. What's the charge on hydroxide? So how many hydroxide do we need for every calcium? 2. There's our formula. Now that we have our formula, we can go ahead and calculate the molar mass. So we have calcium times 1 times 40. And then we have oxygen times 2 times 16. And then hydrogen times 2 times 1. And then we got to multiply straight across. So that's going to be 40, 32, and 2. You add these together and you should get 74. And what's the unit here going to be? Grams per mole. All right, let's go ahead and solve the next one. The next one says how many moles are in 230 grams of calcium hydroxide? So what is our given information here? 230 grams of what? Of calcium hydroxide. What unit goes down here? Grams of calcium hydroxide. Anytime you write grams of anything, you're going to put in the molar mass. So our molar mass is going to go here. And how many moles is that? 1 mole of calcium hydroxide. And that's it. So in your calculator, let's do 230 divided by 74. And then you should get 3.11. And what's our unit going to be? Moles of what? Calcium hydroxide. And then box that up. There's your answer. All right, so this is what we did last semester. Let's keep moving. So what we did last semester was called dimensional analysis. And dimensional analysis, you don't need to write this down. Dimensional analysis is a way of converting from one unit to another. It involves multiplication and division and conversion factors. It says you need to focus on units. Don't worry about that. All right, let's keep going. So I got a quick question for you. So $1 is equal to 1,309 dinars. All right? That's real. All right, so you have $23. All right? Anybody heard that song? You got $1 in your pocket, a 20 in your wallet? Get big?
Oh no, I thought you meant that.
All right. All right, so you have $23. We're trying to figure out how many dinars you have. All right? So we're going to do the conversion real quick. What goes in this box here? $23. What unit goes in this box down here? It's going to be dollars. And then this is where we put in our conversion factor. We're going to put $1 at the bottom, and what goes at the top? 1309 dinars. Now everybody grab your calculators. We divide by the bottom. That gets rid of our unit. And then we multiply by the top. So if you have $23, how many dinars do you have? 30,107 dinars. Do you have, like, ignore the currency. Don't say, oh, I have more currency. Imagine both of these as digital currency. In which case do you have more money? Are you sure? Are they different?
It's the same, but it's different currency.
All right, so it's the same thing though, right? Just a different unit?
No, it's different because you don't know how far a dollar can get you nowhere.
But we're talking about you're right here. You're not going to Iraq to spend these dinars. You're just here. And you converted your $23 to 30,000 dinars. Do you have more or less money than you did before? No. You have the exact same quantity. All you did was you changed the unit. Let me show y'all another example. So $1 is also equal to $17.93 pesos. All right. So if we wanted to do the conversion to pesos, you still have. So it went down. That means that it actually went up. Yeah. But that's good for the people who are over there. It's bad for people visiting, trying to maximize their dollars. But anyway, so you still have $23, and we need to figure out how many pesos that is. So we're gonna put our $1 at the bottom, and then our pesos go at the top. So 1793 pesos, and then go ahead in your calculator. 23 times 17.93. All right, so 412.39 pesos. Do we have more or less money? We have the same amount of money. It might be more currency, like if you had more bills in your pocket, but that don't mean nothing. It's the same. These are equal to each other. This is an equality. Okay. And now back to these equalities. So over here, 1 inch is equal to 2.54 centimeters. Now, any values that are equal to each other, we can put them in a fraction. So 1 inch over 2.54. Now, what is this going to equal when I put it in the calculator? It's going to equal 1. What about 2.54 over 1? What's that going to equal? That's also going to equal 1. They're different units, but it still equals 1. So anytime you have an equality, you can flip it and it's still going to work. Now, in which scenario would I use these different ones? So let's say that my given information was inches. If I was given, let's say 23 inches, I'm going to use this variation. Does that make sense? If I was given centimeters, so let's say I have 300 centimeters, which one am I going to use? Which equality? I'm going to use that one. So 2.54 centimeters goes at the bottom, and then inches goes at the top. Does that make sense? So these equalities, they're just used to do conversion. So we convert from one unit to another. That's all I wanted to show you here. Are we changing the value, though? Yes or no? Are we changing the value? No, we're not changing the value. All right, let's keep going. So let's do a few more molar conversions. We're going to run through these real quick. I'm going to give you 1 lap each. That's it, all right? So how many moles of carbon are in 26 grams of carbon? I'm going to solve this one. I'll let you solve the next one. So what goes in this box here? 26 what? Grams of carbon. What unit goes down here? Now, anytime I write grams of carbon, I need to get the molar mass. What's the molar mass of carbon? It's going to be 12 grams. And how many moles is that? 1 mole. So in your calculator, let's do 26 divided by 12. How many moles of carbon do we have? Well, one more time. 2.17. What's the unit going to be? Moles of what? All right, there you go. Let's go ahead and get the next one. Okay, so to solve this one, what's our given? What goes here? 6 moles of carbon. What unit goes down here? It's going to be moles of carbon. And anytime I'm doing a conversion, it's always going to be 1 mole. So 1 mole of carbon is how many grams? 12 grams of carbon. So it's just going to be 6 times 12. So how many grams of carbon do we have? 72 grams of carbon. All right, let's move on. Okay, so this time we have liters. So liters is one we haven't done yet. So this is going to be the first time we work with liters. But everybody, real quick, y'all want to hear about the biggest scam in DISD history? Yeah. All right, so this guy, he wanted to make some money, right? So he grabs a bunch of pieces of wood, and then he makes these hollowed out boxes. And then he goes to DISD headquarters, and he was like, you know what? I got a thing. I got a thing that everybody need, and it's this box right here. They were like, how much for the box? It was like $80 for this box. And they were like, you know what? We'll buy one for every single science classroom in the district. So if you've been in DISD for a long time, you've probably seen one of those boxes in every single one of your classes. Y'all know what I'm talking about? Y'all seen them before? Yes or no? This box right here. All right, so what that box is actually doing, it does one thing. It tells you how much 22.4 liters at standard temperature and pressure is. So that's going to be liters, okay? So here's what I want you all to write down real quick. So 1 mole of any gas is equal to 22.4 liters, okay? This is at standard temperature and pressure, so STP. We'll talk about STP real soon. You don't have to worry about it right now, though. So 1 mole of any gas is equal to 22.4 liters. If you forget that quantity, where can you find it? Right here. So that's the one value of this box. Anytime you need that number, it's right there. All right? So let's go ahead and solve the first one together. So if we have 26 moles of O2, so 26 moles of O2, what goes down here? What unit? It's going to be moles of O2, 1 mole of O2. And then how many liters is that? 22.4 liters. That's it. So go ahead, plug that in. What's our answer? 582.4 liters. of oxygen gas. Go ahead, solve the next one. You're going to be using the same equality. All right, let's go ahead and solve this one. So what's our given information here? 20 grams of O2. So just so y'all know, I don't care at all about answers right now. I want to make sure y'all are following the process because what we're about to get into, it follows the same process. So grams of O2, what unit goes in this box here? Grams of O2. You know what? This one's a two-step. That's my bad. So our first step here would be to convert to moles because we can't do this in a single step. So grams of O2, that was correct. So grams of O2 down here. What's the mass of O2? 32 grams. That's going to be for 1 mole, right? Of O2. Now what unit goes in this box here? Moles of O2, how many? 1 mole of O2 is how many liters? 22.4 liters. So grab your calculators. Let's do 20 divided by 32. And then we're going to multiply by 22.4. And then you should get 14. And what's the unit for this going to be? All right, 14 liters of O2. Any questions on this one? All right, let's move on. So now we have particles. For this one, you're going to need Avogadro's number. Do y'all want me to solve one or y'all got it? All right, please remember I am recording. All right. Shh. All right. Shh. Do y'all need help with the first one or y'all got it? All right, so real quick, let's solve the first one. How many particles in 26 grams of oxygen? So again, this is a two-step conversion. So in a two-step conversion, we just have to convert to moles first. So our given information here is going to be 26 grams of O2. What goes down here? What unit? Grams of O2. How many grams of O2? 32. How many moles is that? 1 mole of O2. What unit goes in this box here? Moles of O2. How many moles? And then how many liters is that? Actually, no, this is particles. How many particles is that? My bad. All right. Shh. So it's going to be 26 divided by 32. And then we multiply by Avogadro, 6.02 times 10 to the power of 23. And you should get 4.89 times 10 to the power of 23. And that's going to be particles of O2. Hands up if you got this number. All right, good. Let's go ahead and solve the next one. The next one's the same thing, except you're moving. Yeah, it's the same thing. So how many particles in 20 liters of oxygen? Let's go ahead and solve this one real quick. So what's our given information? 20 liters of O2. What goes down here? Liters of O2. So when I put in liters of O2, how many liters is that? 22.4. Good. How many moles is that? 1 mole of O2. What unit goes in the next box? Moles of O2. How many moles? 1. And then how many particles is that? 6.02 times 10 to the power of 23. And that's it. So it's going to be 20 divided by 22.4. And then we divide that, we multiply that by 6.02. And then you should get 5.38. 5.38 times 10 to the power of 23. Hands up if you got this number. All right, good job. Y'all killing it. Let's keep going. So now we're going to start today's material. So up until now, did we change any of our quantities? What have we been doing? Changing what? All we've been doing is changing the units. What we're about to do now, though, is we are going to change the quantities. So let's take a look here. So I'm going to solve these with you guys. But here's the important thing. Shh. I know you can solve these in your head. What I want, though, is I want to see the work, all right? So let's do these together. If I have 6 cups of sugar, how many eggs will I need to use all of it? So this is a stoichiometry problem. And what we're going to do is we're going to plug our given information. What's our given in this problem? 6 cups of sugar. What unit goes here? Cups of sugar. And then we need to look at our equation. Our equation tells us 1 cup of sugar. So 1 cup of sugar requires how many eggs in this recipe? 3 eggs. So it's just going to be divide by the bottom, multiplied by the top. We get rid of our unit, and then 6 times 3 gives us 18 eggs needed. That was easy, right? All right, let's go ahead and do the next one. I'm going to give y'all 1 lap, and then I want the answer from you guys. Make sure you're writing the units. That's the important thing, all right? All right, so this one says, if you have 8 cups of flour, how many cookies can you make? So what's our given information for this one? 8 cups of flour. Shh. What unit goes down here? Cups of flour, how many? 2 cups of flour. And then how many cookies will that make? 25. So it's going to be 8 divided by 2. That gives us 4 times 25. How many cookies can we make? 100 cookies. Any questions on this? All right, let's move on. All right. So here's the new material. So today we're going to be talking about stoichiometry and mole ratios. So what is stoichiometry? Stoichiometry is the mass relationship between different substances based on mole ratio. So it's exactly what we did on the previous slide. Except we're not always talking, I don't say 3 eggs. Instead, I'll say something like 500 grams of eggs. Make sense? It's a mass relationship between different substances. And it's based on the mole ratio in either that recipe or that chemical formula. Next definition, yes, you need to write this. Next definition is mole ratio. This one's crucial. So what is the mole ratio? It's the ratio between 2 compounds, and that's just going to be the coefficient in the chemical equation. So this semester, you're not going to be balancing equations. They're going to be given to you balanced. So your mole ratio is just based off of what you see in that chemical equation. I'm going to give you all a couple laps to write this out. All right, so let's go ahead and take a look at these real quick. So what is the mole ratio between magnesium and oxygen in this equation? What is our mole ratio? It's going to be 2 to 1. So you're always going to be looking at the coefficients. I had a student who was trying to convince me, no, you have 2 oxygens. But these oxygens, you got to remember, are chemically bonded to each other. They're basically one molecule. So our ratio here is going to be 2 to 1. Okay? What about magnesium and magnesium oxide? What is our ratio? It's going to be 2 to 2 or 1 to 1. Either of those is acceptable. All right, and then the last one is going to be magnesium oxide to oxygen. What is our ratio? 1 to 2, 2 to 1, however you want to put it. Any questions on mole ratios? On our next quiz, this is going to be the easy question. Like, you don't want to miss this. This is the easy stuff. All right, let's move on. So I'm going to solve this problem. You don't need to do it. Just watch what I'm doing. So this is a 1-step stoichiometry problem. I'll tell you how you identify that later. If you want to produce 4 moles of MgO, how many moles of magnesium do you need to start? I'm going to change this. I don't want magnesium. I want O2. So that's the only change I'm going to make. So 4 moles of MgO, that's my given information. So 4 moles of MgO. What unit goes down here? Moles of MgO. How many moles of MgO? 2. And then they're asking for O2, so what goes up here? It's going to be moles of O2, and the equation tells us that it's 1 mole of O2. So we're just going to divide by the bottom, multiply by the top. Moles of MgO goes away. So 4 divided by 2 is 2. And what's our answer going to be? 2 moles of what? 2 moles of O2. That's stoichiometry. All right? So this is foundational level stoichiometry. Now, before I have you solve a problem like this, I want y'all to solve the same thing, but with cheese sandwiches. So I'm going to give you guys, I'll give y'all 4 laps. I want you to solve both of these. Make sure you include units. These are both 1 step. All right, let's go. So what's our given in the first one? 28 bread. What goes down here? Bread. And then we're going to grab our number from the equation. So 2 bread. And then how many cheese do we need for every 2 bread? So 1 cheese. So 28 divided by 2, how many cheese do we need? 14 cheese. Now the next one, what is our given information? 30 sandwiches. What unit goes down here? Sandwich. So for every 1 sandwich, how many bread do we need? 2. So 30 times 2, how many bread? 60 bread. Does this make sense? All right, so the next one you're going to do is going to be a chemical equation. So let's go ahead, and I want y'all to try to do both of these solo. I'll give you guys, I think 5 laps is plenty. This one. So let's take a look at this first one. What is our given information? All right, 15 moles of Mg. Make sure you're writing all this down. So what goes in this box here? Moles of Mg. That's the important thing. Now we look over here. Now that's where we get our 2. So 2 moles of Mg. And they're asking for O2. So now we put 1 O2 at the top. 1 mole of O2 at the top. So by writing the units, you know what the next step is. So 15 divided by 2, what's our answer going to be? 7.5. And what's our unit going to be? Moles of O2. So the next one is exactly like it. Make sure, let's go ahead and get the next one. All right, what's our given information in this one? 4.8 what? And then what goes down here? Moles of O2. How many moles of O2? 1 mole of O2. And they're asking for MgO, so what goes at the top? 2 what? 2 moles of MgO. So now we just do 4.8 times 2. What's our answer going to be? All right, that's it. Let's go ahead and move on. These you're going to do by yourself. All right, let's go ahead and take a look at this one. So what's our given information for the first one? 10 moles of NH3. What goes down here? Moles of NH3. And then we could grab our coefficient from here. So 2 moles of NH3. And then they're asking for hydrogen. So what goes to the top? 3 moles of H2. So you're going to do 10 divided by 2. That's 5 times 3 is what? And what's the unit? Moles of H2. Do y'all see how important the units are? Because we have to know what you're talking about. Like in the beginning, we start with one thing. In the end, we're dealing with something completely different. All right, let's solve the next one. Okay, so we have, what's our given? 15 moles of H2. What goes down here? How many moles of H2? And then how many nitrogen gas? 1 mole of N2. So it's going to be 15 divided by 3 times 1. What's our answer? 5 moles of what? N2. All right, good. So here's what we're going to do. We're going to skip number 2. I do want you to do number 1. And then I want you to do number 3. So let me give y'all a heads up. Everybody look at the screen real quick. Y'all see how this one gives you moles and it asks you for moles? Yeah. This is how you identify a 1-step. So everything we've done so far, it gives you moles and it asks for moles. It gives you moles and it asks for moles. That's how you identify all of the 1-steps. Now, when we look at this bottom one, it gives us moles and then it asks for grams. How many steps? 2. This one's a 2-step. So go ahead. I want you to solve the first one and then get the second one. All right, so let's go ahead. Yes, let's go ahead and go over these real quick. So what's our given information for the first one? 28.6 moles of magnesium. Now, what's our unit for this one down here? Moles of magnesium. So here's our magnesium right here. So what number goes for moles of magnesium? And then we're converting to aluminum nitrate. So there's aluminum nitrate right there. So that's going to be 2 moles of aluminum nitrate. And then we're just going to do 28.6 divided by 3 times 2. And what's the number that y'all got? 19.1. What's the unit? Moles of aluminum nitrate. Hands up if you got this number. All right, almost everybody. That's good. Okay, so let's go ahead and work the other one. So this other one it's the first one y'all get. That's a 2-step. It is not more difficult, and I'm going to show y'all two ways to solve it. I'm going to show y'all the right way, and then I'm going to show y'all the wrong way, okay? We'll start with the right way. So the right way to do it is you're going to set up for a two-step. What's our given information here? 10 moles of aluminum. What unit goes down here? Moles of aluminum. How many? 2. And then they're asking for magnesium. So what for magnesium? 3 moles of Mg. So the first step, what we did is we converted to moles of magnesium. Now what unit goes in this bottom box here? Moles of magnesium. Our last step is going to be to convert to grams. So how many moles of magnesium? 1 mole of magnesium. And how many grams is that? 24.3. That's it. Now grab your calculator. We're going to do 10 divided by 2. Hit enter. Multiply by 3. Hit enter. And then multiply by 24.3. And then what's our answer going to be?
364.5 grams.
And what's the unit?
Grams of magnesium.
All right, grams of magnesium. Shh. All right, I need y'all to lock in. So this is our answer right here. Now, are y'all ready for the wrong way to solve it?
No, I don't even want to see the wrong way.
All right, I'm gonna show y'all the wrong way because it's gonna help the people who feel really confused. So here's the wrong way. The wrong way to solve it is solving it like 2 one-step problems. All right. So we're gonna put 10 moles of aluminum here, and what unit goes down here? Moles of aluminum. We put a 2 here. What goes to the top? 3 moles Mg. So our first step is going to be to convert to moles of magnesium. We're just going to do 10 divided by 2, that's 5. Multiply by 3, that's 15. Okay? 15 moles of Mg. Do they want moles of Mg? No, they want grams of Mg. So our next step is we could plug that in here. So 15 moles of Mg. What unit goes down here? Moles of Mg, 1 mole of Mg. And then how many grams is that? 24.3 grams of magnesium. And you're just going to do 15 times 24.3, and that's going to give you this same number here. Does that make sense? So the solving it like a 2-step is the right way to solve it. Solving it like 2 one-steps is not the right way to do it. It works. It'll always give you the right answer, but it's not efficient, especially when we get to 3-step. And a 3-step problem, do you want to solve that like 3 one-steps? No, you're going to solve it like a 2-step. 1 second. All right, let's go ahead and solve the next 2. So both of these are 2-step. And both of these are just like the one we just solved. Okay, let's go ahead and solve these real quick. So if you want to produce 40 moles of MgO, how many grams of O2 do you need to start? So what's our given here? 40 moles of MgO. What unit goes down here? Moles of MgO. And it's going to be 2 moles of MgO. And they're asking for O2, so that's going to be 1 mole of O2. What unit goes down here? Moles of O2. So anytime you have a conversion, it's going to be 1 mole of O2. And then they're asking for grams. What's the mass of oxygen gas?
32.
All right, so 1 mole of oxygen is 16. O2 is going to be 32. That's going to be grams of O2. So then in your calculator, 40 divided by 2, that's 20 times 32. What's your answer? 640 grams of O2. Hands up if you got this answer. All right, so if I haven't caught you today, I need to get you next class. And if I don't, you're really going to struggle with the 3 steps. I don't want to lose you at 3-step. Who needs more time on the next one? All right, I'll give you more tiempo. All right, so what is our given information for this one? All right, 10 moles of O2. What goes down here? 1 mole of O2. What goes up here? 2 moles of Mg. What goes down here? Moles of O2. 1 mole of O2. And then they're asking for grams. Magnesium, yeah. They're asking for mass of magnesium. So what goes to the top? 24.3 grams of Mg. So then it's just going to be 10 times 2 times 24.3. What's our answer going to be? 486 grams of Mg. Hands up if you got this answer. All right, good. Now last slide. Man, don't be like that. All right. So here's our last slide. All right. Here's what I want y'all to do. It's just a diagram. Y'all got this. All right. Do what? Yeah. All right. This is the last thing y'all are gonna do. Everybody, look at my screen. So this is gonna be this line down the middle is mole ratio, and this is gonna be moles of A, moles of B, and then this part right here, I don't need that. All right, so that is not necessary. Everything else is. Next class, we'll fill in those X's. All right, thank you all for watching. Be sure to hit that like and subscribe button.